Pretty easy so far? Okay, cool. Next one is, we now just repeat this process. Which urn has the most? Well, obviously the urn with 4. Okay, so we start at 4 again, and I take half of the pebbles. What's half of 4 again? Oh, Pamela, I see 2. Let's move 2. So now, again, I'm going to take 2 pebbles, remove these 2, and I'm going to put them over in the other urn, to the right. Always moving to the right. 1 to the right, 1 to the right, 1 to the right. Erase my numbers. I now have 2 and 5. Interesting. So I'm going to go to the urn with the most pebbles, urn number 2. It has 5. I'm going to take half of them, rounding down. Show me with your hands. How much is half of 5 rounding down? Peace, everybody, peace. 2. So what we'll do is we'll take 2 pebbles, and I'll move those 2 over here. By the way, special effects does help with this problem. So put 2 over there, erase. I have 2 pebbles, 3 pebbles, 2. We are, I think, almost done. Repeat again. Urn with the most pebbles is the middle one, 3. Take half, round down. I get, how many do I remove? 1. Awesome. You guys are doing great. Okay, put that pebble in over here. Put that pebble in, sorry, just gotta get right over here. So now you can see that I have 2, 2, 3. Uh-oh, almost done. Largest urn is number 3. Hopefully I'm not going too fast now. Okay, yeah, are we going okay? Thumbs up, thumbs down? Excellent. Okay, see my formative assessment in practice. Okay, so 3 urns, or the third urn with 3 pebbles. I take half, rounding down, so that would be 1 pebble. I move it over. Okay. Uh-oh, now we are finished, unfortunately, and you'll see why. So I have urn 1 with 2 pebbles, urn 2 with 2 pebbles, urn 3 with 2 pebbles, and the 4th urn with 1. You'll see the game ends the moment you have more than 1 urn with the most pebbles. So do you see how those 3 urns have the most, but they're all the same? That means I am done the game. So we know 7 pebbles gets us to the 4th urn. I'm going to give you 6 minutes and 21 seconds. What's an odd number I would use so I get to the 5th urn? What number would I use so I end up with the 5th urn? Okay, so try that now. And you'll find out that not always bigger numbers end up with more urns. A mystery.
Dave, there's a question with respect to which app are you using for your iPad for drawing there?
I use an app called Show Me. There is another app, actually, since you can just see my screen, I'll just pull it up. So you can see Show Me is on the bottom right here. I'm highlighting it with my finger, okay? There's another app called Explain Everything. If you have money, or if your division has some money, I would recommend getting that one. The free one sucks, but the premium is amazing. Unfortunately, it costs money. And, well, we all know where that's happening right now in our province. So I would use Show Me. The best thing is, too, I don't know if you can tell on the top, it has a record button. I'm highlighting it now with my finger. So kids can actually just record and type exactly this and submit it into you. So it's called Show Me, and it is a free app. Okay. Chris Gonzalez also said whiteboard.fi. That's another great one. As a teacher, you can see whatever kid's doing. So, okay, we're down to 3 minutes. I'll give you just 3 minutes to play with that Aesop's urns problem. It's a great way to practice division by 2. Boom, boom, boom. Okay, well, hopefully you've had, and I know that this is like an all-day, just joyful problem you could probably do all day. So I'll leave that with you. I've ran that with many grades 3 to 5 classes, and just asking the pattern, like, what's the pattern from 3 to 5 to 7 to 9? But just really quickly, why do we start with an odd number? Why would we start with an odd number of pebbles? I'm looking at the chat. Can anyone want to maybe type in, why would we start with an odd number? Okay, it can't be split in half. True. There's something else, though. Does anyone know? Yeah, exactly. Maria's got it. The moment, if you use an even number, say 10, they use 10. Half of 10 is 5, so you'd have 5 in the first, 5 in the second. Game's over. That's lame. So normally I actually wouldn't tell kids to start with an odd. I actually just start with an odd, and then I ask them, what number should we start with? And of course, some kids just play around and they realize even numbers aren't as fun. And so exactly as someone said, super boring. Okay, it is, right? The more earns, the better. Okay, so hopefully that made sense. That's a good, I like starting with some rich math problems, and that one will definitely have some cognitive tasks to it, especially if you ask them, what is the pattern? Like if I'm just starting with X, or if you wanted to do this, check this out, ladies and gentlemen. This is algebra and expressions in Aesop's urns. Now, I know some of you just probably threw up in your mouth looking at this, but that's okay. This is where some amazing math can happen with some of your enrichment kids. So for those of my grade 5 students or grade 5 teachers and wanting to enrich kids in algebraic expressions, you could definitely do the same task here and just say, what would happen if we made it into algebra? Okay. All right. So here's just the whole idea was essential ideas from grades 3 to 5. I more wanted to just kind of go in case if maybe you're a grade 3 teacher and you don't know where the kids are going. This is definitely not what you should be teaching in grade 3 or grade 4. This is kind of the spectrum from grade 3 to grade 5. So obviously in grade 3, they start with numbers to 1,000, then 10,000, and then grade 5, we end up at numbers to 1,000,000. What I wanted to do here is kind of pick out, as we know, we have a couple months left. Things are very, very stressful to a lot of us. And so what is it, the things that we should be focusing on? These are the things, and then please do not hear this is the gospel or this is in stone. This is just a guideline or an idea from me, I guess. The other things is we would want kids in these grades to mentally add and subtract any 2-digit problems. And I would say that is actually fair from grade 3 to grade 5. So if you're in a grade and you don't have students who can mentally add any 2-digit problems, I would make sure that that's kind of the stuff we should be focusing on. Beyond that, we should be able to add or subtract using personal strategies, okay? The reason I say personal strategies, I've seen a lot of stuff now being going home, and I get it. Right now, it's very stressful. We maybe go to Pinterest, but I'll see stuff like regrouping activities. We just have to make sure that regrouping is, while it's a strategy, it's not actually, like it's part of the curriculum, but it's not, students don't need to per se do regrouping questions. Yes, regrouping is a strategy they need to understand, but we want to make sure that we're more focusing on number flexibility. The next thing is this bullet here, expect from your students what you rely on. The reason I say this is, let's look at the first number, 1,250 minus 125. I think we can all agree that that should be able to be done mentally, I would say at that point. And now, I would say again, from the grade 3 to grade 5 transition. Grade 3, obviously not. At grade 5, yes. But if we get a number like 2,321 minus 1,178, what I would suggest to you right now is I wouldn't worry so much about the second problem if they're struggling with the first one. I think sometimes we kind of jump through the curriculum and hopefully asking kids to come along. And I'm going to show you some strategies on what do we do if we have students who struggle on the first, but while other students can manage the second one. And so I'm just making sure they're cognizant that we don't want students working on the second problem if they have no idea how to start the first. Next is decimals. I know in the curriculum it says limited to thousands. I tell my teachers all the time in Red Deer Catholic, I don't know the last time I needed to work to the thousandths decimal place. And I'm a math teacher. I'm a high school math teacher by trade. Hundreds is what I would worry about. I would want every student in every one of your classes, when you get to decimals, to know how to work with hundreds. That's what our society works with. That's what money works with. And I really believe if they master hundreds, thousands won't be so hard. Okay? The next is, so I got a little baby behind me here coming in. She heard decimals and got so excited. Starting young. Okay, the next is multiplication and division facts. Obviously, we want 9 by 9 mentally. Grade 3, you start at 5 by 5. Grade 4, you go 7 by 7. And up to grade 5, it's 9 by 9. Then the other ones, we want to use personal strategies again. What I worry about right now, and I don't know if you're worried about, is that we have a lot of kids that are kind of probably resorting to traditional algorithms. And again, I'm going to show you some ways that maybe we can make sure that they stay with conceptual understanding. And then the last one is fractions, and we'll talk about that too. But just know that I would say we were going from anywhere from introduction to comparing to relating, okay? Now, the other ones, and I'm just seeing some questions, should I reinforce or can I work on some shape and space? Do not hear, and this is what happened yesterday. You'll notice I specifically left shape and space. I think all those, do not hear me say shape and space is not important. But those are awesome vehicles or lenses you can use to get to these essential ideas, okay? And I'm going to talk about those as we go on. So those people who are asking that, I would encourage you to try to integrate some of the other outcomes through the lenses and make sure that one of these essential ideas is kind of at the heart of it, okay? So what though it sums down to, and I would say this is fair from any grade starting like at least K to 9, is really what we want is number flexibility and joy. And I really can't stress the second part as much as the first. We've all been there. I know we have, whether it's been like, to me, it was social studies where I'm reading a social studies text and I'm learning how to hate social more than I'm actually learning the content. And so what we want to make sure is that's not happening to kids. We don't want kids getting booklets and booklets of math and it's resorting to this kind of mundane work. So hopefully I'm going to show you and arm you today with what I created was kind of a week plan from a grade of 3-5 class, what you could do every single day. And the first is we're going to have some fun, okay? And this is where we're going to start. We are going to start, ladies and gentlemen, on a Monday math talk. Now, I know it's Tuesday, but here's what I'm going to ask you. So you have two questions, either 320 minus 97 or 15 times 12. So Chris is going to put you into a breakout. He's going to give you 5 minutes. You are going to be randomly distributed, okay? And as a group, so one at a time, you're either going to answer, how would you do 320 minus 97 mentally, or how would you times 15 and 12 together mentally? Here's the problem. You're not allowed to use a strategy or a solution that has already been shared in the group. So the first person who talks, I guess you're fair game to use whatever you want. The second person, you have to use something different, and so on. Okay? This is an activity, I'll just kind of premise it before you go in, is what you could do in a class. Is you could ask one of these questions, obviously depending on your grade, and ask students the following. What are 2 different ways to solve the problem? What's an authentic problem such that I would actually use this? And how would I visualize the answer? So those 2 other bullets, if you have time, I don't know, I think 5 minutes is going to go very fast. But if you have time, maybe as a group to talk about when would you authentically go 15 times 12? Or when would you authentically subtract 97 from 320? And how would you visualize that? So hopefully that's making sense, okay? Now, so what I need you to do is I'm going to get Chris to break you out. You're going to have 5 minutes. Get on your chats, talk, and try to solve one of those. But again, the trick is you need to solve it differently than what someone has already done, okay? Chris, are we ready to go?
Yeah, we are ready to go. Just a couple questions came to me. There's a few people who don't have audio or video, and so if that's the case, you can talk through the text box still. You can send messages that way. If you don't get put into a breakout room, it's because you're using a web browser instead of the application, in which case you'll stay in this main room and we'll go through those same things just together that way. So I'm going to open up the rooms and it'll automatically force you to a room and it'll automatically force you back when that's done. So ready, set, go.
All right, see you in 5, everyone. Give them the rounded number and ask them for the discrepancy. So for example, I had a party with about 80 people in it. What would be the most and the least amount of people in the party, right? And so those things, again, would be, those are kind of, I think, better questions to ask. Okay. Yeah, Chris, is the recording back up? I know we had some problems last time.
It is recording once again, yes.
Okay, cool. So hopefully you guys got lots and lots of different ways. What I think is using tools like Flipgrid and stuff, you can do that. But I want to talk about this. And the reason why I share this story, this question right here, and the question I just asked you, has blown my mind to a point I can't even describe. I was in a low junior high classroom, and I'm still confused where the whiteboard is. Lori, can you see the whiteboard? Is that the problem? Okay, you can see? Okay, good. Okay, so I went into a classroom and I put this on the board, 15 times 12. And we did all these explanations and I saw huge things. I heard things like, oh, I see a clock, 12 15s, 12 quarters of a clock. Beautiful, beautiful. And then I saw this person named, we'll call her Tina. I'm going to say to you what Tina said to me. And I'm pretty smart in math. Like, I think I am. But to me, it blew my mind. Here's what she said. Dave, I don't like working with 15 and 12, but I love working with 10. So I'll take the 5 out of the 15, leaving me with a 3, a 2 out of the 12, leaving me with a 6. 6 times 3 is 18, times 10 is 180. Now, if you're like me, she might as well spoke Hebrew at that point, because I have no idea what the heck she said. But I want to show this because of the power of a number talk. If I would have shown the class how I may have multiplied 15 and 12, they really would have heard a lot of kids, let's be honest here, oh, if the teacher does it this way, this is the way I should do it. This is what Tina did. Tina took the numbers 15 and 12 and said, I don't like 50. I'm going to think of it as 3 times 5. 12, that's a little tricky. I'm going to think of it as 2 times 6. Now you can go 5 times 2 and get 10. And you can go 3 times 6 and get 18. Times 18 and 10 together, and I get 180. I have a master's in mathematics, ladies and gentlemen, and I never would have thought to multiply like that until Tina in grade 7 showed me that. That blew my mind. I cannot stress, and I have probably oodles and oodles and oodles of more stories about number talks like this that I could share with you and continue. But I think that's the power of that stuff. I think we don't give sometimes enough kids enough credit. What will they do if we just said go? And how would you do this? And the stuff that I saw over my years of number talks is just amazing. And so I think that even giving this to kids and saying, okay, how would you do this? And I'm going to give you a template later on if case, but even just what I have here on my screen, 2 different ways, an authentic word problem. Okay. I get another one. And the reason I do that, I'll go to the left side, 320 minus 97. I was working with my boss, an associate superintendent, an amazing lady. Her authentic problem was this: if you have 320 cats and you give away 97, how many cats do you have? Which I interrupted her and said, if you have 320 cats, we have an issue here. And subtraction isn't the problem. Friends is, okay? What I'm saying is, and I joke about this, but do kids actually know when they would use authentically 320 in an actual problem? I don't know. And I think those are the bigger ideas here. It's one thing to subtract. It's another thing to know when to subtract, why to subtract, and does the answer even make sense? And so just kind of my thoughts there. Okay, Tuesday comes in. Try a dice chat. So in the chat box right now, what numbers do you see in that beautiful, beautiful picture on the right side? Just chat it up right now. Type in the chat box. What numbers do you see? And I'll let those populate as I continue talking. But hopefully you can start to see lots and lots of different numbers popping up. Okay? I'm going to take over the screen again. Okay, so I see some people sharing. That is awesome. I'm going to take it over on my white pad. And here we go. Okay. So maybe you see, for example, just the number of dice. What I love about this is, sorry, and I should premise this, this is what I think a self-differentiable activity. Students will do what they need to do with this, meaning maybe they want to count by 7s. And so I see groups of 7 like this. And then I'll multiply by 7s and get the answer. That's one thing they could do. Maybe a student is just counting dice, and they're going to say that's 2 dice, 4 dice, 6 blue dice. Maybe they know now there's 6 blue dice, and there's 5 pips on each dice. So that's 30 pips on the blue dice. Students, again, could then do that with the purple dice, the same numbers. How many purple dice times by 2s and so on. I love all the different answers people are seeing. What I love about this, and let's be blunt, the numbers you see and how you see them tell me a lot more about your numeracy skills than probably any worksheet ever would. And so this is a great activity where if we want kids to just find out what do they know, what do they don't know, is ask them kind of, how would you do this? Now, if you look up here, there's a link, bit.ly/count for me. And if you go to this, I know I told the group yesterday, this is what I did on a Friday night, okay? A bunch of dice and an awesome board. And I just made some pictures. But grades 3 to 5, you get something even cooler out of this now. One thing that I see happen a lot is when students are, say, struggling with multiplication. Now, grades 3, you deal with 5 by 5, then 7 by 7, and 9 by 9. So I'm thinking a grade 6 or grade 5 teacher here looking at this and saying, well, what if my students struggle with multiplication? The worst thing we could do is throw them a multiplication chart. And I want you to think about this. A 10 by 10 multiplication chart has 100 numbers on it. 100. If they're struggling, there's 100 blocks that they struggle with further. Dr. Nikki Newton did some work in this. And what she says is, actually, if you want to multiply and you want to really get deep in multiplication, don't go 9 by 9. Follow this progression here. First, learn to multiply by 1, 5, and 10. Then learn to multiply by 2, 4, and 8. And then multiply by 3, 6, and 9. And of course, the only number missing is 7, but no one multiplies by 7, so we don't need that, okay? I'm just kidding. 7 suck, let's be honest. Okay, sorry, my daughter has her hands full of water and wants me to open the, oh, there it is. Okay, so what you'll see now is if you click on these links, 1, 5, or 10, so this is on the bit.ly/count for me, you will get now pictures of dice pictures that I made that would really hopefully reinforce how do you multiply by 1s, 5s, and 10s. And so if you go through that, you can see all those, okay? Then you get pictures of 2, 4, and 8s. So these are really, really kind of focused on 2, 4, and 8. I saw Miranda pop in. I don't know if she's still here. But I want to share this because Miranda out in Olds there, I went into her class and her students needed to count by 4s. So I made a picture like this. The funny part is there were kids in the class counting by 6s, the jerks, because they saw 4 and 2 is a 6. There's another 6. There's another 6. So it was really cool to see how kids could like really think through these kind of problems and see how they would do it. Okay, and then there's 3 6s and 9s. What I love about this, while I see 3 6s and 9s, other kids might see different things. So there's hopefully a resource that you can use, and then a little better that actually kind of goes through the progressions of multiplication for you. All right. The next thing is you can do is, as you can see in here, is share them with kids, have them do a flip grid, maybe even just a Google Doc, all the different numbers they see, how do they see them? But then even cooler, ladies and gentlemen, is have them make them. Have them post these pictures in their windows. I know we see art walks. Art is good, math is better, okay? So we put some lovely dice pictures, maybe some dot pictures in their windows and say, how would you count them? You could integrate fractions in here. So my higher groups, grades 4 and 5, you could talk about what fraction of dots are on the blue, what fraction of the dots are on purple. Symmetry, just look at this beautiful picture. The lines of symmetry, oh my God, I just didn't even realize, I just saw a diagonal line of symmetry. Okay, see, crazy stuff, just enjoy it, okay? But what I would do is, again, as we know things are asynchronous, we can't kind of do what I just did here. So what we can do is, there we go, okay, is maybe you post it on a flip grid, maybe you post it on a digital whiteboard space, give them a day or two and debrief, okay? All right, or better yet, and I was just thinking about this, what if you actually gave kids and said, here's the numbers I saw, what was a possible picture I was looking at? Could you draw me a dice picture that I saw these numbers? That might be interesting and interesting to see what kids are doing. Hopefully that makes sense. Is that good? I'm gonna check the chat. Is this going okay? Yes? Awesome. I love dice chats. All good. Good. Okay, next one. Now we get to Wednesday. Okay, which one doesn't belong, or would you rather Wednesday? Why? Because it's alliteration and everyone loves alliteration. So which ones don't, I'm not gonna go through this, just kind of looking at some time, but if you click on this, it will get you to a whole bunch of pictures like the one you see on the right column here, on the right corner. So again, how these work, you post these to kids, 1/2, 5/3, 2/5, 2/10, and you ask them which one doesn't belong. And then no matter what they say, you ask them this, can they come up with a reason why each of those 4 fractions does not belong with the other 3? So how could a 1/2 not be used? How could 5/3 not be there, 2/10 and 2/5? Now, if you've never done these with kids, you do have to teach what I would call our trivial answers. So trivial answers, I call them non-interesting answers, right? So 5/3, it's the only one that, I don't know, is in the top right corner. Well, that's a trivial answer, not interesting, okay? So that's kind of what I would do with that one. The next one is would you rather. So would you rathers, if you click on that link, gets you a whole bunch of these if you look in the bottom right. This is a great way to teach ratios, talk about fractions, to talk about ordering, all in an authentic situation. So a picture of 2 liters of lemonade versus 4 juice box. Now, someone did say earlier, how would you integrate shape and space? This is a brilliant way. Imagine you show them a rectangular prism that's kind of like taller and thinner, and a rectangular prism that's wider, and say, which one would you rather have if you were collecting candy? Which one would you rather have if you were collecting dirt or carrying things? those now, do you see, we're going to integrate area and volume and all that stuff, but we're going to do it through a lens of something greater, which is really multiplication. I really want to know is, do students know when to calculate volume? Or give the same two pictures and say, we're not going to carry anything, we're actually going to paint them. Which one would you rather paint? Because now you're not saying surface area, you're hinting at it. And I think those are the ways that you talk about and get those, and I don't want to say less essential outcomes, because don't get me wrong, volume and surface area are essential. But if kids know how to calculate volume, but struggle with multiplication, then it's going to appear that volume's the problem. But in reality, number sense is. And so we got to make sure that I think anyways, that number sense is kind of always in the center, or if something of number flexibility should always be in the main area. And I say always with a caveat, 80% of the time. Of course, we don't want kids always working with numbers. Math is so much more than just numbers, okay? Make sense on Wednesday, okay? And again, this doesn't have to be done on Wednesday. This could be done just one day, okay? The next one is, I call it Trixie Thursday. Here is my challenge to you if you haven't done already. Once a week, ask a problem you don't know the answer to. Now, I want to be clear when I say that. That is not ask a problem you don't know how to get the answer. But ask a problem that you may not know right immediately. I'll talk about the difference there. We could ask, what's 97 plus 3? Better question might be, how many ways can I make 100 if I was to use a large number and a small number? Or how would I make 100 if I use two numbers more than 100 and two numbers smaller than 100, but all those numbers are really close together? So I think of those ideas where we could, oh, I guess that doesn't make sense, like more than 100, less than, all close together. But what I mean is that when we ask those kind of open-ended questions, and open-ended questions are great, just Thursday is kind of now to really, really pull out those ideas. What you're looking at is open middle problems. If you haven't seen open middle, again, click on it. If you have, this is great. But I think, again, is we do often where I wanted to enrich these, where we just give a question like this. So fill in the blanks with digits, so 0 to 9, to make the answer closer to 100 or 200 than 300. Or this, how would you add, using the digits 1 to 9, so that this is a whole number? Interesting. Now, that's a great start. I think a better one, though, is you'll see the answers to the left, or the questions to the left. How many answers are there? And I love asking, what's the best or coolest answer? And the reason, again, I say this, I use these words, coolest or lamest answer, all the time with kids. Why? Because what they think is a cool answer tells me so much about their thinking, so much. If they think what I think is a mundane answer cool, it might tell me that there's maybe a possible block in their understanding somewhere. I also get some very interesting problems, really cool problems. And I also would do this one, the last one, is it's awesome to have kids working on other people's products. It's amazing to have kids creating their own. So now that if you've ever done open middle and you haven't transitioned to can you make your own, try it. And ask them, can you make the problem that has many solutions? Can you make a problem that only has some solutions? Or can you make a problem that looks like it has a solution, but it doesn't? And the reason, again, I say that is too often, well, every single textbook problem does this. There's always a nice, succinct answer. Wouldn't it be awesome if kids worked on problems that we struggle on and that we actually teach them that struggle is okay and not knowing what to do right away is all right? Just some things I'm thinking. Okay, so there's some Trixie Thursday. All right, and then we get to Funky Fraction Friday. Isn't that awesome? Okay, Tammy, I don't know if Tammy's here, but Tammy was in here, and I had the amazing opportunity to go into her class. She was running in this fraction, and what you're seeing is, and I shared with all these, all these links will take you to the lesson plans, but I'm just going to more talk about them. But if you go to Funky Measuring Tape, this was such a fun activity. I think I modified this from a Joe Bowler, but what it is, and you could do this at home, and the kids could just take pictures, is, actually, you know what, I'll just click on it. Probably easier for me to explain as we go. So if I click on Funky Fraction Measurement, is you just get kids to take a piece of paper, any kind of piece of paper at all, and so you can see I have this. Now, obviously, I was in the actual authentic classroom. You could do this video, but you make up a term for your tape. I called mine I wanted to call it a martini, but a martarini, okay? So these are martarinis. And then we talk about, okay, so if this long tape, this length of tape, say this long is 1, what would be half and what would be a quarter? And what you have to do is you have students creating these kind of fractions to their made up measurement on this, and then they measure with fractions. And they come up with that in all these different ways to create fractions along. And of course, everyone's tape will be different, and it's really great. What I'll do is I'll pull it up. There's a little measurement sheet here. They can fill out and submit it to you digitally. So what's the item? Describe what you did. What's the measurement? The actual measurement and the estimation. So this was a really cool activity where we had kids kind of making this kind of paper thing. Of course, we did it in an authentic classroom. This could be done digitally. Everyone has a piece of paper at home somewhere. If not, tell the parent to cut off a strips of a normal 8.5 by 11, cut it off somewhere. Okay. Someone's asking the whiteboard app. This is the, it's called Show Me is what I've been using. Okay. The next thing is decimals on a number line. So another one is, it's a little funky game. They roll some dice, they throw some decimals on, and the idea is to get fractions and decimals inside other fractions and decimals. So this is another activity, very, very low tech. They could do it right from home. And for those who are trying to organize decimals and fractions, there's a really cool activity there. I'll let you just explore these on your own, just depending on everyone. Because I really want to dig deep and spend about 5 to 10 minutes here on one of my coolest, not my coolest sites. Nat Banting from Saskatchewan created this amazing Fraction Talk website. What I want to show you is this. It's literally this easy. You just take a picture. This is a picture off his site. And what I want you to do, I'm going to give you 2 or 3 minutes now, is in the chat box, tell me what fractions do you see? If I was to shade in some of this picture, some, not all, but some of this picture, what kind of fractions do you think I could shade in? You got 2 minutes. Look at that picture now. Type in the chat. What kind of fractions do you think I can make? Go. Oh, look at that. 1/2, 1/4, 1/4, all even numbers up to 16ths, wholes, quarters, halves. Yeah, yeah. Awesome, awesome. Just look at the math. Look at the fraction fun that is happening in the chat. Okay? Now, that is one thing you can do. The opportunities with this are just endless. I'm going to go back just kind of a is this. One activity is this. You give the kids a whole bunch of fractions, the same image just duplicated a bunch of times, and ask them exactly what I just did to you. What are all the different fractions you can make? And I love the Logan who went 1/1. That is beautiful, a whole one right here. And what you're seeing is this picture is, now the idea is that every picture has to be shaded differently. So if you see half differently, and you can see the half up here is different than the half way down here. So the fractions are equivalent, but the shading is different. See, ladies and gentlemen, these are the things that are really hard for us to understand as learners when it comes to fractions. But we take this for granted all the time, right? I see a lot of time where we say, okay, 1/2 is bigger than 1/4. Now, without context, that may be true. But 1/2 isn't always bigger than 1/4. What? Yeah. 1/2 of the people in this room is smaller than 1/4 the size of Red Deer. See, without context, these fractions don't really have meaning to them. And so I would say, especially early on, there's a brilliant way to ask that question. When is 1/2 not equal to 1/2? When the half is of a different whole. And so these are ideas that, like I think of all the time working with kids with fractions. In fact, actually, you know what? I'm going to take this because I got to share this with you. This is a funny story. Just recently, working with kids, and I'm going to take it over my screen. So there's always a 3-second delay. So I went into a class once, and I wanted to see how could they do equal sharings. And so what I did was, I'm just going to pull up my show me, I said this. Imagine you have 5 cupcakes. 3 of the cupcakes have icing on them. 2 do not. How would you share these cupcakes among 4 people? How would you cut this equally? No word of a lie, ladies and gentlemen. I got the best answer. I thought I knew what the best answer was until the grade 4 student did this. Well, first off, no one eats cupcakes without icing, so we really only have 3. And I loved it. It was beautiful. Never thought of this. Throw away 2 ugly cupcakes. But what was great about this is these are those ideas where I never would have, this is a whole different idea now in this child's mind. But these are authentic problems now, as opposed to saying, how do we distribute 5 among 4? Give them some creative constraints. The fancy word is, yeah, creative constraints. And so how would we do that? And so that was just a fun little activity that, again, just putting some things on different, like just so you're not just saying, how do we share 5 among 4? How do we share 9 among? Put some different constraints on it and some different things may happen. Okay, so I'm going to just go into the Fraction Talks here website, just so in case if you've never seen it. I'm looking at time here, but you can see there's squares, there's triangles, manipulatives. Of course, there's a whole bunch of digital space that kids can make these things on their own, polygons and photos, okay? So this is kind of what I would say if I looked at your grade 3-5 curriculum, a possible week plan. You got some number sense in there, you got some area. Now the person who said with 2D, 3D shapes, you definitely can integrate this in your number plans here, is how many different squares can you make inside a square, such that maybe one big square when you have 3 smaller squares. Again, the whole idea though is the fraction part at the center of it. And I'm going to use the lens of 2D and 3D shapes in a way to do that, okay? The last thing is all on Friday, because it's Friday and fun. I don't know if you've ever seen these, but these are amazing, is logic mazes, okay? So logic mazes is just a great time. Like, oh, it's a great time. I don't know if you've ever thought of a maze as a problem, like as an actual really rich problem, but this one's so great. So if you click on logic mazes, I've played with all of these. I'm just gonna jump to number 5 because it's an applet online. This one's so cool. How this works is you start and you're at a 4. I have to move 4 spots. So I either go 1, 2, 3, 4 and move to that 3, or I can go 1, 2, 3, 4 and move to this 3. I'll move to, say, this 3. Now that I'm here, I have to move 3. So say 1, 2, 3. Now I'm here, I have to move 2. 1, 2. The goal here is to get to goal. Again, this is a great entry-level problem. Have lots of fun. Talk about different solutions. But what's always cooler is getting kids creators and asking them, create your own grid that has an easy solution, a hard solution, and so on. Oh, you know what? If you wanted to have, I don't know what integers would look like, but you could even make a maze with integers. I know integers aren't introduced right away, but sorry, I'm just getting excited of higher level math, okay? But there are some different logic mazes. There's mazes in there that you cannot take a left turn and so on. Okay, so there's a whole bunch of stuff, hopefully for 1 week, all right? Got 9 minutes left. If there is one thing that I can tell you, math is all around you. You are looking at a picture. I saw this ginormous dice. Look at that die. Look at that 20-sided die. That's the size of a child's head. And all I did was took this picture and I created a which one doesn't belong about it. I just saw this. I am telling you, I got way more engagement. I think it's because kids knew that I was the creator of this. Look around your house. There is math all around you. And I guarantee, take stuff, integrate it into your classroom, you'll get a much, much better payoff because kids know that like this isn't just something we found on the internet, but it's actually what I have in front of me. Here's another problem that I had. I was sitting at, this obviously was before quarantine. I did not go to a pub and take this, okay? This was way before COVID-19. But what you're looking at is my friend Renee. I don't know if you've noticed this, but she is the same height in both pictures. On the left, she is standing. On the right, she is sitting. Say, what? Beautiful. Here's a beautiful, beautiful algebraic problem. How tall is Rayanne? Now with this though, and I love these kind of questions in here, is that I would definitely pose this on a Monday as the question, how tall is Rayanne? The question in Monday would be, what questions would you like to ask so I can give you more information? When I asked this in an authentic class, do the kids, for example, one kid asked, what's the height of the table? I gave it to them. I Googled the height of a regular table. Of course, we know that's not a really important question in this. But again, I want to make sure that I know students, are students aware of what questions to ask and what questions are not important? Because I find most, say, word problems, give the information in the order they need it, right? And then I follow it up by a nice, beautiful formula that they just plug numbers in. So these are the kind of problems that I think now that we have kids at home, we can actually maybe pose it, they can think about it, ask some questions, and then Tuesday we debrief, here's all the answers. Do we need more questions? Do we have enough information? And so on. Michael Pierce, or yeah, Kyle Pierce has a whole bunch of three-act math tasks. So I'll write that in the chat actually right now. Or Chris, can you write that in? 3-act math tasks. If you Google that, it has the same kind of idea about this, okay? All right, I'm gonna go through now my last kind of options, some things that, in case you don't like those 5-day ideas, is first off, here's a template for a math talk. So if you go here, this is based on what we call the Annie, or not what I call, out of BC, there's two awesome guys that created the ANI, Assessment of Numeracy and Education. But here's a beautiful way you give this to kids that they could authentically capture everything we just did. So in the middle, you would throw your naked number problem. Maybe that's 32 plus 15. Maybe that's 82 times 7. They would do a visual solution. They would calculate it with numbers, a different visual solution, and write a real-life example. This is a way that we could capture everything that I asked you to do in the breakout, okay? There's an estimate up here, too. If you don't like that, we can just say estimate and explain strategy. And here's an example of how it might look like in an authentic classroom. Of course, this is an authentic class. In a digital space, you would just have to fill this in. But of course, you could fill this in. Don't think always everything has to be this fancy schmancy technology. I see a lot of people asking, how am I using my iPad? That's a show me. But if that's intimidating to you, then don't do that. Just do it on paper, take a phone and take a picture of it. Please, don't become super teacher overnight, right? That's how we turn into alcoholics. So we don't want that from you. The next one is, I saw this. This is a beautiful way, is choice boards. Now this is a grade 2 example, but you can definitely see how the flow, I was gonna create one for 3 to 5, I just haven't had the time, my apologies. But where again, they use the ideas, the strategies that I kind of was showing you through, but having it across. So as opposed to would you rather on a specific day, would you rather and which ones don't belong every day. And then how this works is students pick one of these to do each day. So either the top or the middle. And then here's a game they would play at the bottom. All right. Again, this is just a way we know abundant amount of research out there. If you want kids intrinsically motivated, we have to give them choice. We just have to. Or we have to at least be what we would say the fancy word is, in their zone of proximal development. The problem is zone of proximal development means you're asking a question that's either just like they're accessible to or just a little bit out of reach, but they still are motivated to do it. But of course, if your classrooms are anything like the classrooms I go in and work with, the class complexity is through the roof. So this is a way that you can actually kind of get a personalized zone of proximal development with kids, okay? Next one is mobile math. Oh my gosh, mobile math. If you have not seen mobile math, here goes your Friday night, okay? Date night solved. This is a beautiful, beautiful app that you can play and build, and it's a really fun way to get kids playing with algebra without knowing it, okay? So I'm gonna click on play. If you haven't seen this, I'm just gonna click on run randomly, this one here. And it says, interesting, this is 8, and it's balanced. It's balanced. So right away, we could say, well, we probably know how to make 8 balanced, 4 and 4, but if you don't, I see that, oh my God, it's 2 of these little shapes, and that is 2. So 2 plus 2 is 4. So that means the moon must be 4. If I put 4 in and hit submit, I don't know if you heard that, it's an amazing star thing, and it does that. But it does something cooler too. There's something that I actually love about this. Let's pretend I get it wrong. Look at this feedback. Look at that. It actually shows me that 5 is heavier. And if I use a 3, it shows me the other side is heavier. That right there is a visualization of how to show that the error is wrong. I think such a cool applet. Solve me problems, and of course you have whatever level you want. You can go to master. Like, look at this joyful problem right there. Hey, I know. Oh, geez, just look at the fun. Okay, but there's a whole bunch of ideas. There's a whole bunch of problems in there, algebra on how to figure all these out. The beautiful about this, grades 3 to 5 kids don't even know it's algebra. They think it's fun. They think it's glorious, and it absolutely is. Okay, 3 minutes. Math flips is another one. I'll just let you click on. Whoops, I clicked on it. I'll just it's a visual way of looking at different number ideas from the gentleman Berkeley Everett. Okay, he's great. At the end here, though, is I've showcased some of my top strategies for grades 3 to 5. But if you click on this rdcrs.ca/math activities, you get everything that gem I have ever found. So some of these are in here: mobile, weekly math tasks. Oh, graphing stories are great. You show a video and kids got to make a graph about it. It's awesome. Math mistakes, play with your math. Bovine cows and math. How fun is that? Menu tasks, all in there. These are just, and then for those who, that Friday puzzle, if you go to math puzzles and games, here's a whole bunch of, again, activities that I would say are just not just for fun, but there's actually some heavy mathematics into it. Okay? The one last thing I wanted to leave every session with is this. You're not online teaching. Unless you've been trained for it, maybe you are. But I think what we have to always remember, we're trying to do our best during a pandemic. critical funding cuts, and unknown timelines. And babies. And babies, okay? Babies everywhere. Help me. Help me. Okay? But anyways, what I want you to always remember is that we're not online teachers, or some of you may be, I know I'm not, but this is exactly what, like, we just got to make sure that we're doing what we're best we can. And I know you are. And so continue doing it as best as you can. Try to integrate with kids. Try to use your environments as mathematics. I guarantee it's all around you. And if you ever have questions or you ever need to reach out, there's my contact information, teacher.davidmartin@gmail.com. I'm the Math Council president, but you can also reach out on Twitter at D_Martin05. But yes, feel free to reach out anytime. I try to answer emails within 48 hours, and I will get back to you as fast as I can. So I will leave you at that. If you have any questions, I will stick around. Hopefully you got something out of it. And happy counting, everyone. Woo!
Awesome, Dave. You are amazing, and thank you so much for your energy and your excitement. This is awesome. I know that you've given us some great strategies and everything, so that's been awesome for us. I'm just going to quickly here show before we leave here. I want to just quickly show. I want to show something, but it won't show me. I just want to show quickly that there's a lot of people asking. Dave's email or Dave's PowerPoint is there, and if you look in the chat, you'll be able to see that. Also, if you look at where we're going to find this recording later on, if you go to bit.ly/ATAPD resources. It's going to bring you to this page here. And so the association has been starting to develop some resources for teachers, but really what you want to come to is this tab over here. And you're going to click upcoming and recorded webinars. And so what you will see is the upcoming sessions that we have. Dave is back again tomorrow in grade 6 to 9. So if you're close, if you're a grade 5 teacher and want more, join us next week for sure. And you're welcome to be able to join us there. But all the sessions that we've done or are doing are going to be on this site. We update it every Friday, try to by 1 o'clock, but typically by 4 o'clock on Friday, we have our next sessions for the next week. If you weren't with us and you wanted to see some other recorded sessions, you can come over filter by type, or you can just look at the days. So I know that if you look over your technology tools and you're someone who said that you'd just like some support in Google Classroom, Google Docs, Google Forms, Screencastify, you can click on any of those. And if it says recording available, you just click on there, and then there'll be this yellow, green, whatever color that is, recording link that you can have access to. So today, hopefully, well, I shouldn't say today, hopefully by tomorrow afternoon, we should have this session here up and recorded if there was no technical difficulties, and we'll continue to try to do that for you as well. So as Dave said, we'll hang around. If you've got questions specifically for either one of us or just want to chat, you're more than welcome to hang around. But we do like to finish on time, so it is 2:01, and thank you so much for your attendance here today. There is, in this SCAD account, there is an opportunity for you to do an evaluation if you'd like to do so, but we've just really enjoyed having people here, and thanks again, Dave. You are inspiring every time I get to hang out with you, so take care, everybody.